Each of the dot plots shown represents the number of glue sticks brought in by each student for two classes, Class A and Class B. The statement best compares the standard deviations of the number of glue sticks brought in by each student for these two classes. So we see that we have two dot plots showing the number of glue sticks brought in by each student, or how each of the numbers here represents how much an individual student brought. So like this dot here represents that a student brought in 3 glue sticks, and since there are 3 dots above the 3, that means 3 students brought in 3 glue sticks each. And we're asked to compare the standard deviation of the two plots. So the standard deviation really just measures the amount, the level of how spread the data points are. And if we look at the shape of the dot plot for Class A and Class B, the shape is identical. We see that it starts off low and increases. And the dots are actually identical for both. The only difference is that the numbers on the scale down here are different. But since the shape of these two dot plots are the same, that means that the data has the same level of spread for both plots, and that means that the standard deviation for both of these plots is the same. So the correct answer choice would state that the standard deviations of both of these plots is the same, since the shape of both of the plots is the same. So A is incorrect because it says the standard deviation of the number of glue sticks brought in by each student for Class A is less than the standard deviation of the number of glue sticks brought in by each student for Class B. That's incorrect because the standard deviation should be the same. One should not be greater or less than the other. B says the standard deviation of the number of glue sticks brought in by each student for Class A is equal to that of Class B, and that's correct. And then C says that one is greater than the other, so that's incorrect. And D says there's not enough information to compare these standard deviations, and that's also incorrect. We have enough data here to physically calculate the actual standard deviations themselves because we have all of the data points. We have that how much because each of these dots here is an individual student, and we know exactly how many glue sticks they brought. So you could calculate the mean and the spread of the data, but there's clearly enough information to determine that the standard deviation is the same since the dot plots are identical.